All right, take a look around you for a second. Seriously. The chair you're on, the air you're breathing, the screen you're looking at. What if I told you that all of it, I mean all of it, is made of the same basic stuff? Scientists call this stuff matter, and today we are going to break down what it is and how it all works. So let's just start with that big, kind of wild question. Is the solid chair you're sitting on, the invisible air all around you, and maybe that hot coffee you're sipping, could they all really be built from the exact same building blocks? It sounds a little nuts, right? But that's exactly what we're here to figure out.
Believe it or not, for hundreds and hundreds of years, this was a massive debate. Early thinkers had two completely different ideas about what the world was made of. It was a real showdown of ideas.
Okay, so on one side, you had the idea that matter is continuous. Imagine a solid block of wood. The idea was that no matter how many times you sliced it, you just get smaller, perfectly smooth blocks with no gaps. Then, on the other side, you had the particulate view, that everything is made of tiny, individual bits, kind of like a beach is made of countless grains of sand. So, who was right? A smooth, unbroken block or a pile of tiny little particles? Well, turns out we can settle this ancient debate right now, and all we need is a little trip to the kitchen. Let's run a little thought experiment. Picture a glass of water, and you mark the water level with a pen. Got it? Okay, now you stir in a spoonful of sugar, mix it all up until it completely dissolves. But here's the weird part. The water level barely changes at all. So what happened? Where did all that sugar go? And that is our answer. The sugar didn't just vanish into thin air. Its teeny tiny particles just wiggled their way into the invisible empty spaces between the water particles. This super simple experiment proves it. Matter is particulate. It's made of tiny pieces with little gaps in between them. So now we know that everything, you, me, this planet, is made of these little particles. But what are they actually doing all the time? Well, their entire secret life can be boiled down to three simple but super important rules. It really all comes down to these three golden rules. First, like we just saw with the sugar, particles have spaces between them. Second, and this is a big one, they are always moving. Always. They never, ever stop jiggling around. And third, they are attracted to each other, kind of like tiny little magnets. Let's zoom in on that constant motion idea. Have you ever been way in the back of the house and suddenly you smell someone cooking something amazing in the kitchen? You're not imagining things. That's rule number 2 in action. Now, this whole phenomenon has a fancy scientific name. It's called diffusion. It's just the natural process where particles of one thing mix with particles of another thing, all on their own. Those tiny smell particles from the food literally travel from the kitchen, bumping and weaving through the air particles until they fly right into your nose. And you've probably noticed this too, right? You can smell hot food from way further away than cold food. That's because heat gives particles more energy, specifically kinetic energy, which is just the energy of motion. So more heat means they zip around way faster and spread out much more quickly. Okay, so how do these three little rules, spaces, motion, and attraction, explain the world around us? Well, they're the reason we have the three main states, or as I like to call them, the three personalities of matter: solids, liquids, and gases. This table really breaks it all down. See, whether something is a solid, a liquid, or a gas just depends on how much energy its particles have and how strongly they're pulling on each other. In solids, they're packed in super tight, just vibrating. In liquids, they've got enough energy to slide past one another. And in gases, they've totally broken free and are just flying all over the place. Let's pop back to the kitchen, because it's the perfect lab. A solid is like an ice cube. Its particles are locked into a grid, holding their shape. A liquid is like water you pour into a glass. Its particles can flow and slide around to take the shape of the container. And a gas? That's the steam blasting out of a kettle. Its particles have so much energy, they just fly off in every direction. Okay. I can practically hear you thinking this right now. But wait a minute. If solids are supposed to be rigid and have a fixed shape, what about a sponge? I can squish a sponge into a tiny ball. So, is a sponge not really a solid? Ah, but the sponge material is a solid. The trick is that the sponge is filled with tons of tiny little holes, and those holes are filled with air. When you squeeze it, you're not actually compressing the solid sponge part, you're just pushing all the trapped air out. So the rules for solids totally still apply. So we've got our three states, but things aren't stuck in one form forever. In fact, by adding or taking away energy, which usually just means heating things up or cooling them down, we can make matter change its state.
This diagram shows the whole dance perfectly. You add heat to a solid, like an ice cube, its particles start vibrating like crazy until they break loose and become a liquid. We call that melting. Add even more heat, they start flying apart as a gas. That's boiling. And of course, the whole process works in reverse if you cool things down.
But here's a cool thing. A liquid doesn't actually have to boil to become a gas. Think about a puddle on the sidewalk after it rains. It's not boiling, right? But after a while, it disappears. That's evaporation. It's a slower process, and it can happen at pretty much any temperature. And here's something you have definitely felt. Evaporation actually makes things colder. When you get out of a swimming pool, you suddenly feel chilly, right? That's because the water on your skin is evaporating. For those water particles to escape and turn into a gas, they need a little boost of energy. And where do they get it? They steal it right from your skin, leaving you feeling cold.
All right, we have covered a ton of ground. But before we wrap this up, I want to leave you with one final little puzzle, a really interesting case where the rules we just learned seem to get broken.
Think about this for a second. We said that in solids, the particles are packed together more tightly than in liquids. That means a solid version of something should be denser, so it should sink in its own liquid. And for almost everything in the universe, that's true, but not for water. So why on earth does solid ice float? And the answer is, well, water is just plain weird and special. When it freezes, its molecules actually arrange themselves into a crystal structure that takes up more space than when they're a liquid. That makes ice less dense. It's this incredible exception to the rule, and it's a perfect reminder that in science, just when you think you've got it all figured out, you find a new puzzle that proves there's always something amazing left to discover.